Hey guys, today we're working with lesson 4.4 of triangles, and we're actually going to be going one step further than proving triangles congruent. So we're still going to have to prove triangles congruent, but we're trying to talk now about the corresponding parts. Remember at the beginning of the chapter, we talked about what are congruent polygons, and that's when all the corresponding parts, like the angles and the sides, are congruent. All right, well, we're going to use the fact that we've been using just 3 parts to prove triangles congruent and then find the other missing congruent parts. So remember our first 5 methods of proving triangles congruent. We had the side, side, side congruence. We had the side, angle, side congruence, our SES congruence. We had the angle, side, angle congruence. We had the angle, angle, side congruence, and hypotenuse, leg congruence. So I'm really excited because now we get to apply those, but now we have to have a reason to use them afterwards. We want to prove other stuff besides. So we have what's called CPCTC. It's the following: corresponding parts of congruent triangles are congruent. That allows us to find the pieces that go together. And we abbreviate that in geometry, CPCTC. Now, corresponding parts of congruent triangles are congruent. Now remember, corresponding parts are sides and also, gotta love the bell going off, sides and also angles. So, let's explain how you can use side, 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 angle, angle, and angle, angle, side, or hypotenuse, leg with CPCTC. Now, all of these are proof statements. I want to prove these are true. You cannot assume them if you're going to prove them. What you can assume is just from the diagrams right now. So really, it's a lot like what we did the other day. How can I prove the two triangles congruent? Then, how do I explain it? So basically, we're going to be doing like mini proofs without showing every single step. We'll do the other proofs in the back. So the first one, I want to prove angle A is congruent to angle C. Notice I have a pair of sides. Because I have a linear pair, I have a pair of congruent angles. And because segment BD is congruent to itself, we have another pair of sides. So we can say by the SAS congruent triangle BAD is congruent to triangle BCD. So, since I know those two are congruent, what do I know about angle A and C? Look right here. So, angle A is congruent to angle C by corresponding parts of congruent triangles are congruent. And that's basically what we're going to do. You're going to have a section literally like this, 1 or 2 problems on your test that's doing the same thing. So let's do the next one. Notice we have a pair of angles, Ooh, I need a pair of sides. So I look at this diagram and go, oh yes, reflexive property, I have a pair of sides. Oh look, that's angle, side, angle. So we do the same thing. By angle, side, angle congruence, triangle HEF is congruent to triangle. If we go HEF, we're going to go FGH. So, what do we have now? Segment HE is congruent to segment FG by corresponding parts of congruent triangles are congruent. And we keep going through all the other examples doing the same thing. We're going to prove angle K is congruent to angle P. Notice right here I have 3 pieces of information. I have a right triangle, I have a pair of hypotenuses, and a pair of legs that are congruent. So I can say the same thing over here. By hypotenuse leg congruence, triangle, let's go JKL, is congruent to triangle. And now remember matchy matchy. If I go JKL, I'm going to go NPM by, so, but I got to make sure I'm focusing here. Angle K is congruent to angle P because we know corresponding parts of congruent triangles are congruent. Basically, this is an abbreviation for the definition of congruent polygons, so we want to use it to our advantage. All right, let's get the next several down here. I want to prove angle QST is congruent to angle SQR. Well, I have a pair of angles, Oh, look, a pair of sides, angle, angle, side. So by the angle side congruence triangle, let's go QTS, is congruent to triangle. If I go QTS, I'm going to have to go RSQ. Got to play our matchy green. So I know angle QST is congruent to angle RSQR. I'm just sitting there watching. I had QTS. I should have an S. I should have an SRQ. I just realized I flipped mine around. Otherwise, it wouldn't work. All right, SQR by corresponding parts of congruent triangles are congruent. All right, let's keep going. I want to prove angle U is congruent to angle W. Notice no angles here, but I have side, side. Oh, look, side. So by the side congruence, triangle VUX is congruent to triangle VWX. So what do we know? Angle U is congruent to angle W by corresponding parts of congruent triangles are congruent. All right, let's look at the next one, number 6. So segment ZA is congruent to segment AC. I want to prove those. Now I'm looking at these, and we should be noticing right now vertical angles. Hopefully, guys, we're starting to catch how we can always prove these triangles are congruent. We're actually doing like visual proofs. So on the next one, we'll just say, hey, angle, side angle when I mark it, by angle, side angle congruence, triangle YZA is congruent to triangle. If I go YZA, we're going to have to go BCA. So we know segment ZA is congruent to segment AC by corresponding parts of congruent triangles are congruent. And Lord, I also just want to sit there and keep working with this one and on and on. Guys, the reason why we're repeating this so much is we want you to be able to recognize these over and over. So here, notice, reflexive property comes up again. So I have a side, angle, side. It's included between the two sides. So again, we'll just go by side, angle, side congruence, triangle DEG is congruent to triangle FEG. So I know segment FG is congruent to segment DG by corresponding parts of congruent triangles are congruent.